Alright, so we're going to continue looking at section 2.2. And what we're going to look at today is how we can figure out the coordinate for an angle that's either 30 degrees, 45 degrees, or 60 degrees. And these coordinates, they all involve square roots. So we saw lots of square roots come up yesterday. And I didn't really explain to you where the square roots were coming from. I just said, here's a coordinate. You don't have to worry about how to figure it out, because I gave it to you. Well, today, we're going to have to figure out some of these coordinates. Right? So that's how all the problems are going to be set up today. You're going to have to find a coordinate first. And then once you have it, you can do what we did yesterday. Do the sine, the cosine, and so on. So what we're going to do is we're going to start by looking at this case. We're going to look at the case where you have a 45-degree angle. So here's my unit circle. Okay, we did 0, and we did 90, and we did 180 and 270. Those are the ones we did yesterday. Where's 45 degrees in relation to 0 and 90? Yeah, it's right in the middle. Okay. What's going to happen today with our angles is the one that we're looking at is either going to be right in the middle between two that we've already done, or it's going to be closer to one, or it's going to be closer to the other. Okay, but those are kind of the three places that the angle could be today. Middle, closer to the x, or closer to the y-axis. So 45 is right in the middle. So let's actually let's go like this. Let's take this. Let's take that and let's draw a unit circle on that. What's the size of a unit circle? Yeah.
It has a radius of 1.
Has a radius of 1. So I'm going to go like that. And there's a unit circle. So what we're looking at is a 45-degree angle. Right there. Now, sometimes people, when I ask for what do you think the coordinate is, they say, oh, 1, 1. If you did 1, 1, would that be a point that's even on the circle? No. 1, 1 is up here. It's not 1, 1 to get to 45 degrees. Okay, I hope you can see that. It's a little bit less than 1, and then another number that's a little bit less than 1. Okay, we have to figure out what those numbers are. Okay. It's not 0.5, 0.5. 0.5, 0.5 would land you in the dead center of that box. Well, that point's not in the center of the box either. Okay, so what is it? Well, you got to figure that out. So here's the same diagram. I'm just going to make it a little bigger. All right, so to figure out what these coordinates are, what we're going to do is we're going to make a triangle, okay, for each one. The way you're going to make the triangle is you're going to draw a radius from, roughly where you think 45 degrees is, to the origin, and then straight down, just like that. So this is a 90. This angle right at the origin, right here, is 45 degrees, because that's basically the angle I tilted the hypotenuse at. So it would be exactly at a 45-degree angle. Now, how about this angle at the top? What would that angle at the top have to be, right?
45.
It would have to be 45 because they all have to add up to 180. So what we've got here is a 45, 45, 90 right triangle. And it's a special right triangle. And there is one side that we already know. Somebody tell me what side of the triangle do we already know the length of? Caleb?
Well, what I thought, I forget, is it like the hypotenuse or something, is 90, or is 1 because it's 1 radian?
So the hypotenuse is 1 because we're dealing with a unit circle. and the length of the hypotenuse is the radius of the circle. So same triangle, I just made it a little easier to see. Now, unfortunately, that one doesn't directly help us because our goal is this. What goes there and what goes there. In a coordinate, the first number always represents what value? The x. And x is what kind of movement? Is that vertical or horizontal?
Horizontal.
That's horizontal. So x, what we're looking for is the distance from here to there. It's how far over you would have to go. And then the other thing we're looking for is how far up. So to figure out the coordinates for 45 degrees, we really have to figure out the lengths of two sides in the triangle. How far over do you go from the origin? That's the base of the triangle. And then how far up do you go to get to the point? That's the height of the triangle. Now, we don't know the base or the height yet, but if you did know them, how would the length of the base and the length of the height compare to each other in this triangle? Yep.
They would be the same.
They would be the same. And that's the whole key to figuring out this coordinate. So whatever the coordinate is, the base and the height, which will give us the x and the y, they're going to be the same two numbers. Any question on that? And if you're not sure why they're the same, it's because 45, 45, 90 is an isosceles triangle. If you have two angles that are the same, then you also have two sides that are the same. All right, if these two sides are the same, then we just need to pick a variable to represent them. And we're going to pick the same variable. So a lot of times you pick two different variables, one for the base and one for the height. Let's just use the same one because we know it's the same thing. So let's use x to represent the length of the base. And that means the height will be the same thing. It doesn't really matter what letter you use. We're just picking a letter so we can set up the Pythagorean theorem. That's all. All right. So what, how could we set up the Pythagorean theorem with the three things I have labeled in that triangle? X, x, and 1. We said that, huh?
A squared plus b squared equals 1.
Okay, we just have to make sure we use these, because we don't have any A's and B's up there.
So would it just be x1 plus x, like 2 equal 1? Or would you literally just use 2x?
You have to use the labels that we have exactly.
Okay, so x squared plus x squared.
Yep, x squared plus x squared equals 1 squared. Okay, so there's the Pythagorean theorem using those three sides. Any questions on setting that up? All right. What's my next step in simplifying that equation and solving for x? What could I do next? No?
Combine the x squared,
Yeah, we have like terms. What's x squared plus another x squared?
2x squared.
Yep, so we have two of them. And I'm going to do out 1 squared, which is just 1. And now we have 2 steps left to solve for x. And remember what we're solving for. We're solving for the length of the side in a triangle, which is going to give me the coordinate. Okay, how about, Caitlin, what's my next step to solve for x?
What if we divide by 2?
I'm going to divide by 2. I'm just going to copy it over here so I have some more space. So we have x squared equals 1/2. And what would be my last step now so I get x by itself? Ellie?
Would you square root it?
Yep, I'm going to square root it. And remember, when you square root both sides, if you have a fraction, you do the top and you do the bottom separate. So on the left, the square cancels out. And on the right, Justice, what's the square root of 1? Just 1. And unfortunately, the square root of 2, we can't simplify that, but we also can't leave it in the bottom. So what do I have to do to fix the square root in the bottom? And this will give me my final answer. Yeah.
Multiplied by square root of 2.
Multiply by the square root of 2 over the square root of 2. And what do you get, Noah?
You would get 1, or you would just get square root of 2 over 2.
Yeah. You get the square root of 2 over 2. So using the Pythagorean theorem, we solved for this length, which we called x, and we solved for this height, which we know is the same thing because it's an isosceles triangle. So we know the distance from the origin to the end of that red line. We know the distance from right there straight up to the coordinate. So anyone think they can tell me what I would write down for the coordinate of 45? Yep.
Square root of 2 over 2, comma square root of 2 over 2.
Yeah. It's square root 2 over 2, comma, square root 2 over 2.
Like if you're trying to build something.
And now that we know that coordinate for 45, that never changes. We don't have to go back and figure that out again. That's always the coordinate for 45 degrees. So now we know the x and we know the y. We can do whatever we want to do with it. Okay. So any question on how we figured out that coordinate? And this was a problem we had yesterday in the notes. You really already have done the 6 trig functions of 45. The difference yesterday is I'm not telling you the coordinate now. You have to remember it from what we just did. But yesterday I gave you this exact coordinate as an example in your notes. I think it was example, might have been 2, but you've already done this problem. Yeah.
Okay, so in this situation where, let's say I'm trying to make something, right? And then there's a circle and then I want to build, like, let's say supports that go through. How could I turn that into a number that I could then use to cut something out, like cut a piece to fit what I need?
Like
Real
you were building
expectations.
like a ramp or something?
Yeah, just like, I don't know, I'm just trying to think of an example where you could use that number as something to
Yeah.
make something else, you know what I mean?
So if, let's say you knew the length of your ramp was going to be 10 feet.
Mhm.
Of course, to support a ramp, you got a mite at the end.
Right.
You know, so it, you know, the piece, whatever the support is, it's flush to the angle. So if you knew you were going to set a ramp at a 45-degree angle and it was going to be 10 feet long, and you wanted to figure out how long the support at the end has to be, well, all you'd have to do is take 10 feet. And I would just use the decimal to make that easier. Square root of 2 is about 1.4. Because, I mean, if you're cutting a piece of wood, you don't have to be accurate to the millionth of an
Right.
inch. Right? So 10 times 1.41, well, it's not going to be that big. 10 times 1.41, and divide by 2. So that would tell you the length of the support you need. If your ramp is 10 feet long, you need about a support 7 feet long at the end to support it.
So it's about, so the x value in our case would be about 0.07 if we converted that.
Yeah.
Okay,
It'll be 0.7. Yeah,
okay.
it's about point. Yeah.
I was just trying to see if you could actually take that number and turn it, like our square root of 2 over 2 can then be turned into an actual like number value.
Yeah.
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 That's what I
It's about. This is about 0.707.
Okay.
So if you had something at a 45-degree angle, all you have to do is take the length of your ramp, multiply it roughly by 0.7, and that'll tell you the support you need at the end.
Okay.
It would also tell you how high your ramp would go. You know, you got a 20-foot ramp, and you're going to put it at a 45-degree angle, and you want to know how much elevation you're going to gain from that. Well, multiply your length of your ramp by 0.7, and it would tell you. Of course, you have to figure out a different number for every angle.
Right.
So if you got a 40-degree ramp or a 30-degree ramp, every ramp is different.
Right.
And you could also use 45-degree angle in plumbing to figure out like an offset if you have to cut around an object to pipe around something. You can use the number 1.4 to get an offset, which will basically make your pipe go out and around an object, if you had to. Okay, any other questions on that one? All right, so let's see if we can find the 6 trig functions of 45 degrees. All right, anytime you want to do unit circle trig, what's the first thing that you have to know about your angle?
Its location.
Yeah. Yeah, you've got to know the point. If you know the angle, that's not really what you need. You have to know where the angle is, not what the angle is. Well, we've already gone through all that, so we're not going to do it again. What's the location for 45 degrees? Allie?
Is that the square root of 2 over 2?
So that's your x and your y?
Square root of 2 over 2.
Square root of 2 over 2. Yeah. All right, so now let's go through all 6. Natalie, what would my sine be? Yeah, which one did you pick, the x or the y? X, that's the cosine value. So it's the y. So sine is the y value. I think in almost every problem on the test, the x and the y are not going to be the same. So if you mix them up, it will come out. But here, you get one. So sine is the y, cosine is the x, and Mia, how do I find my tangent?
You would divide
Yeah, you're going to divide, imagine putting a division sign right there. You're going to divide the y by the x, and what do you get if you divide those two? Well, how does the y and the x value compare to each other? They're both the same, and you're dividing them. So, 1. Doesn't matter what two things, if two things are the same, it doesn't matter what they are. If you divide them, you're always going to get 1. Right? And just because I think it's going to be a quick one, the cotangent. Emma, what's my cotangent? 1. It's also 1, because if you flip 1, you get 1. It stays the same. All right. How about Ethan? How do I do my cosecant? Yep, take the reciprocal of the sine, which would be
2 over
square root of 2. And when you fix that so the root's not in the bottom, what do you get? So if we multiply top and bottom, you get 2 times the square root of 2. What's still in the bottom?
2.
Yes, 2. And that would reduce to
Square root of 2.
just the square root of 2. Yeah, we end up doing this one a lot. So the hope is kind of by the end of the week, you'll remember when you have 2 over root 2 and you flip it, it just turns into root 2. If you don't remember it, not a big deal. You can go through and figure it out every time, but it's easier if you remember it. And how about the secant of 45 degrees? Shouldn't have to do too much work for that, Gina.
The same thing as the one with the square root of 2.
Yeah, it's the same thing because the sine and the cosine are the same. So you're just flipping the same thing again, you're going to get the same answer. And there's all 6 trig functions for 45 degrees. Any questions on that? All right, now let's go back to this for a second. So here's my unit circle, and we just did 45 degrees. And we figured out the coordinate. Well, there's 4 different 45-degree angles on this circle. There's one in the first quadrant, 1 in the second, 1 in the third, and 1 in the fourth. This one is 135, 225, and 315. I'm not going to go through all of them today, because this is more, we're going to take a lot, like more of a look at this tomorrow. But anybody have a guess what the coordinate for 135 is? Jason?
Negative 2 squared over 2.
Did you say that again?
Negative squared or. Oh, any left one? Can you pick someone else, please?
Yeah.
Negative square root of 2 over 2, and then square root of 2 over 2.
Yeah. So negative square root 2 over 2, comma square root 2 over 2. So what I'm trying to show you is whenever you're dealing with a 45-degree angle, it's going to be all square root 2 over 2's. The only difference is going to be, do you make one of them negative, both of them negative, or the other one negative? But that's the only difference when you deal with a 45-degree angle in a different quadrant. Negatives come in. We're going to spend more on that tomorrow, but I just kind of wanted you to see it today. The other way you can think of it is if you make a triangle like this. The triangle for 135 is a mirror image of the 45. It's a reflection. That's why the coordinate is the same, but the x value is negative because you're in quadrant 2. You're going left, and then you're going up. Okay. Any question on that idea? We're going to do more with that tomorrow. All right, so we did that. And let's take a look at the other case we have, which is the 30, 60, 90. Okay, so I'm going to start with a 30-degree angle. This is 0. This is 90. So what we're going to figure out right now is what is the length of two sides in a triangle, just like we did before. Now we're going to do it for a different triangle, 30, 60, 90. All right, so this would be like, if you want to make a ramp at a 30-degree angle, it's 10 feet long. How much elevation are you going to gain from that? How big does the support have to be at the end? There's all kinds of other ways you could think about this if you're building something. All right, so 30 degrees, just an estimate. It's about 1/3 of the way through the quadrant. Okay. It's definitely less than half, but more than 0. And we're going to make a triangle, just like we did before. And what side do we again know the length of in this triangle? Yeah.
The hypotenuse.
We know the hypotenuse because it's still the radius of a unit circle, which in this case is how much?
1.
1. So we still have a hypotenuse of 1. So let's go to the bigger triangle. The 30-degree angle is right there, because that's the angle that you're tilting your object at so that it hits a 30-degree angle with the horizontal. And how do I know this at the top has to be a 60? Yeah.
Because triangles equal 180, so in order for, because you already have 1 degree, which is 90, so you have to make 90 with the other 2.
Yep, exactly. So if this is 90, then those two together have to be 90 as well. So they all add up to 180. All right, so let's try to think about how we would do that with the Pythagorean theorem. Is that an isosceles triangle? No. So we can't use the same trick of labeling the sides the same because we're going to get the same answer we did last time. And this isn't the same triangle. This is a scaling triangle, which means all the sides are different. So technically, if you were to try to use Pythagorean theorem right now, which we're not, you would have to label this side x, this side y, but that's not going to work because now you have two different variables. You'd have x squared plus y squared equals 1. We can't solve it if there's two variables. So, we can still use Pythagorean theorem, but we have to figure out one of these other sides a different way first. We got to do something different. Okay, and my hint is going to be to take this and go like this. Like that. That's my hint. Any thoughts on what I do with that? Yep.
The other to make a square.
Okay, we could make, I don't know if we could make a square, but we could make a rectangle. Like if you just rotate this around like that.
Sure.
What are we thinking? I mean, you could have flipped it as well. All right, close enough. So basically I have a rectangle now. Yep, definitely a rectangle. 90s and 90s in each corner. Opposite sides are congruent. It's enough to prove it's a rectangle. Now what? Yeah, I don't know either. People usually suggest making a rectangle, but I don't know what to do with that. But I like the idea of combining them together to make a new shape. I like that. Any other thoughts? Yeah?
Could you mirror it and make a bigger triangle?
Okay, we can make a bigger triangle. There's a couple ways we can do it. Which way do you want to flip it? Up, down, or left, right?
Like completely flip it around so the 90 degrees will be touching and the 30 degrees will be touching.
Okay, yeah, that's the way we want to flip it. So that's a vertical flip. We're going to put that right there. Okay, so now I want to look at what we just made. We have a bigger triangle, but can anybody tell me anything about that bigger triangle? Yeah?
It's equilateral.
It's equilateral. 60, 60, 60. Equilateral means what?
Both sides are the same.
All sides are the same. So I already know two of the sides. They're labeled as 1. But I also know that this side is 1. Now, how does this part in red compare to this part in green? Justice?
They're equal.
They're equal, right? Because those triangles are a mirror image of each other. So the part in red and the part in green are congruent. So we can put that mark. So they're congruent, but together they add up to give me a length of 1 because that's the equilateral triangle. So if they're congruent and they add up to 1, that means each one of them has to be how much? Yep.
0.5.
Has to be 0.5. Now we know the length of the short side just by doing a little trick. And now we can use Pythagorean theorem. So I don't really need the bottom triangle anymore. I mean, you can keep it there if you want, but I don't need it. Okay, so now I know this side is 0.5, or you could do 1/2 if you want. I mean, probably easier to think of it as a half rather than a decimal. And now we can get the bottom side using Pythagorean theorem. Just pick a variable for it. Doesn't matter what you call it. But the point is, you only have one variable now. You don't have two. Yep.
In a 30, 60, 90 degree triangle, will that side of the triangle always be half the hypotenuse?
Yep.
Okay.
The short leg is always half the hypotenuse in a 30, 60, 90. So if you were making a ramp, that's a real easy one to figure out. You got a ramp at 30 degrees. It's 20 feet long. What's the support at the end? 10. It's always half the hypotenuse. And the leg, well, that's always something else too. Let's find the bottom leg and see what we get. Can someone set up my Pythagorean theorem for me using those three numbers? Yeah, Ethan?
X squared plus 1/2 squared equals 1 squared.
Okay, so x squared plus a half squared equals a 1 squared. 1 squared. All right. So now we'll simplify. What's 1/2 squared? Or 1/2 times 1/2? Yeah, Tyler?
A quarter?
Yep, quarter. So we get 1/4 equals 1. We got to move that 1/4 to the other side, and how do we move it? We're going to subtract it. So I'm just going to go over here. What's 1 minus 1/4? 3/4. And my last step, just like we had in the other triangle, to get rid of the exponent of 2. Yep, Hallie?
Square root.
We're going to square root it. Except this time when we square root, we actually get a nice answer in the bottom, which means we're done. So we get square root of 3 over 2. All right, so let's look at our triangle. The length of this side, which I'm just tracing over in black, is root 3 over 2. And the height, which I just did in green, is 1/2. So, based on those two numbers, you know the horizontal distance you need to move, and you know the vertical distance to get to a 30-degree angle. So, what is my coordinate for 30 degrees? Yep, Peter.
Square root of 3 over 2, comma, 1/2.
I think that's a coordinate we saw yesterday at some point. Square root 3 over 2, comma, 1/2. Now, that's the coordinate for the 30, but we really don't need to do that much work to get the 60. We don't have to go through this whole thing again. Right, let me just go like that, so it looks a little cleaner. So here's the 30. Here's the 60. So the 60 is 2/3 of the way through the quadrant. How does the first triangle I drew and the second one that I just drew, how does it look like they would compare to each other? Like if you cut them out and then put them on a piece of paper and looked at them. Yep,
They'd be the same.
they're the same. They're the exact same triangle. The first one that I just drew in red and the second one that I'm drawing in blue, the only difference is what side is it kind of standing up on. The red one is on the kind of the long side, and the blue one is standing up on the short side. So based on that, anyone think they can tell me the coordinate for 60? Yeah,
1/2 square root of 3 over 2.
yeah, 1/2 square root 3 over 2. So the thing that can be tricky with the 30 and the 60 is trying to remember which one is which. Well, let's look at this triangle. One half as a decimal is 0.5. Square root of 3 divided by 2 is about 0.87. Okay, it's bigger. So square root of 3 over 2 is a bigger number than 1/2. Which angle is bigger here, 30 or 60? 60. The bigger angle always goes across from the bigger side. The smaller angle always goes across from the smaller side. And 1/2 is always smaller. So 0.5 is always across from your 30. That's how I remember it. 0.5 always goes across from the 30. Whether it's down here, or whether it was over there in that case. So if I have to do a problem with a 30 or a 60, usually I make a quick sketch. It doesn't have to be perfect. It has to be good enough that you can see where's the short side and then where's the long side. One of them will be on the x-axis and the other one will be going with the y-axis. All right, so let's try this one. Find the 6 trig functions of pi over 6. Well, first, does anybody remember what pi over 6 is in degrees? It's probably just going to make things a little easier, yeah?
30.
That's a 30. So this is a problem about a 30-degree angle. Now, I know 30 involves two numbers, 3 over 2 and 1/2. I have to get them in the right order. If you can't memorize them, then draw a sketch. put 30 degrees. Make a triangle. If you draw your sketch somewhat reasonably, it should be pretty easy to see where the short side is and where the long side is. In this case, the short side is blue. What number is the short side? That's always your 1/2. So in this case, that goes vertical. So the 1/2 is my y. And the long side is always what other number? Yep, Allie.
Square root of 3 over 2.
The long side is always the square root of 3 over 2. I look at the long side here. It's horizontal. That means it's my x. So the coordinate here, without having to scroll back up and remember which one was which, I just figured it out right here. Square root of 3 over 2, comma, 1/2. Now you've got your x, you've got your y. This is no different than any problem you've done. All right, let's go through all 6. Let's see, how about, Jade, can you tell me what my sine would be?
I know that it would be 1/2.
Yeah, the sine is the y, and this time 1/2. Done. Okay, Ryan, how about my cosine?
It would be square root of 3 over 2.
Yep, cosine is the x, square root of 3 over 2, and that's it. Justice, how do I get my tangent?
I can't really pi over 6.
Just how do I get it? You don't have to tell me like
Oh.
any of these numbers. What's the formula for tangent?
When I do y over x.
Y over x. So just imagine putting a division sign right there. You're going to divide those two fractions. And Kavani, if I divide those, what would cancel out?
The denominator.
The denominators. So I'd just be left with a 1 over square root of 3. And when we fix 1 over the square root of 3, what do you get when you write that properly? No?
Square root of 3 over 3.
Square root of 3 over 3. Now, while we're here, let's do the cotangent. What I have circled in red and in black are the same thing. That's why there's an equal sign between them. Well, kind of had the same thing pop up in the homework. You can choose which one to flip. Which one would be better to flip when we do the cotangent?
The red,
Why the red?
because the square root would be on top, so you don't have to change it.
Yep. If you're going to flip one and they're the same, let's flip the one that's less work. Flip that, root goes to the top, and we're done. Okay, Dylan, how about my cosecant? What's that going to be?
Should be 2.
2. Well, we're just going to flip the sign. And anyone think they can give me the secant? The final answer we would write down. Yeah.
2 times square root of 3 over 3.
Perfect. So he flipped it and he fixed it so the root wasn't in the bottom. So there's all 6 trig functions for 30. Okay. Any questions before we finish up with doing the trig functions for 60? Okay, now when we do 60, all that's happening is the x's and the y's are switching places. So I would expect to see all the same answers again, but in different spots, because that's what's happening. All right, so what if you take a couple minutes and see if you can get the 6 trig functions for 60 degrees. Sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. If you get stuck or you just need a little help with something, just let me know. All right, so let's see how we did with the 60. First of all, what's my coordinate for 60? Yep. Yep, 1/2 square root of 3 over 2. So now we'll go through our functions. Tyler, what's my sign?
Square root of 3 over 3.
Yep, that's my y. Let's get that. Bridie, what's my cosine?
1/2.
1/2. And how about Caitlin, my tangent?
I got the square root of 3.
Yep, the 2's cancel, we get just the square root of 3. Perfect. Haley, what's my cosecant?
I got 2 square root of 3 over 3.
Yep, that's perfect. The secant, that's a quick one, you just get 2. And how about Tyler, what's my cotangent?
Square root of 3 over 3.
Good, square root of 3 over 3. Now, if you compare all those answers to the ones we just did, scroll down a little bit. These two answers switch places, the 1/2 and the root 3 over 2. These two answers switch places, the 2 and the 2 root 3 over 3. And those two answers switch places. But it's all the same answers we got for the 30, we got for the 60. All right, so homework tonight is a worksheet. Questions 1 through 10 are on Schoology, so you're gonna have to go to Schoology to get those. And then there's these additional 5 questions. Each problem is set up so that it's a coordinate and an answer. You only have to do 1 trig function per question. But I'm gonna look for what did you write for a coordinate, and then what did you put for the actual answer. Any questions on that?
Are those on the worksheet or we're doing those extra?
1 through 10.
1 through 10 are on a worksheet on Schoology, and those 11 through 15 are extra. So you're gonna have to go to Schoology to get the rest. It's a PDF.